Colby, math.com.
The focus of our current unit on two-dimensional is on two-dimensional geometry and measurement, and one of the big ideas in this unit is the idea of the difference between rational and irrational numbers. And the reason for that is because we start to deal with the most famous irrational number, pi. But a rational number is a ratio of two integers. For example, the ratio 1 to 4 expressed as a decimal is 25 hundredths. The ratio 1 to 3 is also a ratio of two integers. Clearly, it can be written as a fraction, and that's 0.333, and the 3 goes on forever. So sometimes we have a terminating decimal, sometimes we have a repeating decimal, but as long as there's some pattern to the repeating part of the decimal, then it's a rational number. It can be expressed as a fraction. This terminating decimal, in fact, has a repeating part. It's just repeating zeros. And so these are rational numbers. An irrational number like pi can only be approximated as a decimal. 3.14159265. It goes on infinitely, but there's no repeating pattern to this decimal portion. And so it can never be expressed exactly as a fraction. It can be approximated as a fraction. The most common fractional approximation of pi is 22/7, but it can never be represented exactly as a fraction, so it cannot be expressed as a ratio of two integers, and therefore it's irrational. But it's important to be able to understand how to convert rational numbers from decimal form to fraction form. I'm regretting at this point that I'm not on the right slide here. I'm going to start you with problem number 4. But I'm not going to remake the video because I liked that introduction. Okay, if I want to convert this fraction, which is clearly rational because it's a ratio of the integers 17 and 36, I need to understand that the vinculum, the fraction bar, is called the vinculum, and it indicates division. Vinculum is a fancy math word for fraction bar. So this is the same as 17 divided by 36. And so if we just simply divide, we'll get the decimal, the standard form, the decimal number for 1736. How many 36s in 1? 0. How many 36s in 17? 0. But I would like to keep dividing, so I express 17 as 17.0. which is what it always was. The 0/10ths just weren't showing. I haven't changed the value of 17, I've just expressed it as 17.0, which is its value. And by doing that, I can line up my decimal and my quotient and ask how many 36s are in 170. You might try it on the side and find out 108 is close, but I can go higher and realize 144 is as close as I can get without going over. So 4 36s is 144. When you subtract, you get 26, a difference of 26, and then you simply reveal the 0 in the hundredths place and bring it down. 260 is not quite twice as much as 144, but it's close. So this is even going to be a 7 or possibly an 8. And so I'll leave it to you to finish the finding this quotient, but at some point you'll have some repeating portion to this decimal, as we would expect since we know it's a rational number by definition. And then please express that decimal with the repeating portion in bar notation. So you'll finish that one on your own, but I'd like to spend more time on this one because converting a repeating decimal to a fraction form requires some algebra, which we learned in class today. Now, I know that every student understands that watching the video is considered part of doing the assignment, but I know that's not always possible, so I just want to tell you that sometimes you get extra information by watching the video. And what I'm going to tell you, the extra information I'm about to give you, is that these last 4 problems where you're converting a repeating decimal to a fraction using algebra are well beyond the scope of 6th grade, even advanced math. And so I I weight those problems accordingly when I determine your grade. So in other words, if you're struggling on 5, 6, 7, and 8, first of all, you'll have number 8 because you're watching the video. But those final 4 problems don't count for nearly as many points as the first 4. So just know that I take those things into account when I'm grading. But what we learned in class today, if you'll refer to your notes, is that if I want to know what this number is, I can express it as a variable. So I'll just say x is 0.259 repeating, so the 9's go on forever. And then I can do some algebra by finding some way to manipulate this variable, to manipulate this decimal so that I get only the repeating portion after the decimal. And I could do that if I move the decimal 2 places to the right, which is the same as multiplying by 100. So 100x would be equal to 25.999 repeating, because move the decimal 2 to the right. Then I need some other expression of this decimal that then moves another digit forward. So 1000x would be equal to 259.999, and we do that so that we can subtract away the infinite decimal portion of these numbers. And so I'll set that up over here. 1000x minus 100x will be equal to 1000x is 259.999 repeating, and 100x, which we're subtracting away, is 25.999 repeating. And so during the pause, I want you to think about, what is 1000x minus 100x? I'll give you a hint. It's the same as 1000 of anything minus 100 of that thing. What's $1,000 minus $100? The only difference here is you're counting x's, you're not counting dollars. And so figure out algebraically what that difference is, and then referring to your notes, remembering what we talked about in class, represent this difference here, and then try to solve for x. Do that during the pause, and then come back and see how you did.
Paused.
1000 of anything minus 100 of that same thing is 900 of that thing. So 1000x minus 100x is 900x. Just like $1,000 minus $100 is $900. The nice thing about setting it up this way, and the reason we had these algebraic expressions of this decimal in this particular way, is that the decimal part will then subtract away. 9/10 minus 9/10 is 0/10. 900 minus 900 is 0/100. If all of these digits become 0, then the decimal portion is just gone, and we're just left with this whole number difference, which is 4 1s and 3 10s and 2 hundreds. So 900x is equal to 234. Now, solving this algebraic equation is something we'll focus on a lot more this year, but the way you do it is, if we want to know what x is 1x. Isn't this 1x? Well, in order to find 1x, and if I have 900x, I need to divide by 900, because 900 900ths is 1. And then those will factor out, and I'll just get 1x. But if I divide the left side of the equation by 900, I must also divide the right side of the equation by 900. That's called the property of equality. And so I get 1x equals 234 over 900, which is the same as saying x equals 234 over 900. But we're not done, because this isn't simplest fraction form. Now you can see that both the numerator and denominator are even numbers, so we know they're multiples of 2, and you could start with that, but even better than that is to look for a greater factor. And when I add these digits, 4 plus 3 plus 2 is 9. 9 plus 0 plus 0 is 9. So both the numerator and denominator are divisible by 9. And if you don't remember divisibility rules, we'll also focus on that a bit later this year. 234 divided by 9 is 26. So 234 over 900 is the same as 26 times 9 over 100 times 9. And then the 9/9 factor out. We factor out a common factor, and we get a simpler form of our fraction. We're not done yet, because that's not simplest form, but I want to stop here because 26 hundredths is a decimal fraction. It's just 0.26. And so we're saying that this repeating decimal is exactly equal to 0.26. We're saying 2.26, 26 hundredths is exactly, not approximately, exactly equal to 0.25999 repeating. And this is the same idea that we talked about in class, that 1 is the same as 0.9 repeating. And I didn't believe this when I first when someone was trying to explain this to me. I didn't believe they were right until I wrestled with this idea of infinity long enough and convinced myself that it was true. But you see that same idea representing itself in this fraction. But in order to finish this 26 hundredths, we need to then divide by 2 halves and get our ultimate simplest form, which is 13/50ths. And so that's the solution to number 8. And do your best on 5, 6, and 7. And just keep in mind that, like I said, I am counting those problems, but I'm not weighting them nearly as high as the first 4, which is more important for this year to understand how to turn a fraction into a repeating decimal. Thanks for watching the video. I'll see you tomorrow.